The AP Statistics, the first day's homework. Number 1 says, here's a small part of a data set that describes the fuel economy and miles per gallon of 1998 model motor vehicles. First of all, part A says, what are the individuals in this data set? If you look back at individuals, we said that individuals are the objects described by a set of data. They may be people, but they also may be animals or things. So the individuals that we're talking about here is specifically the cars. And if you look, we have a BMW 318i, and then we also have the Buick Century and Chevrolet Blazer. But those are the individuals, the cars that we're talking about. And then for each individual, so for each car, what variables are we talking about? So if you look beside the car, you'll see the different types of variables that we are talking about. And I'll give you a hint, there are 5 of those. And then you want to know which ones are categorical, which means which ones can be grouped by words, and then which ones are quantitative or can be grouped by numbers. When we go to number 2, we talk about medical study variables. It says data from a medical study contains values of many variables for each of the people who were the subjects of the study. Which of the following variables are categorical and which are quantitative? So again, you'll go through A, B, C, D, E, and F and tell which one you can group into words, which would be categorical, and which ones you can group into numbers, which is quantitative. All right, number 3. You want to compare the size of several statistics textbooks. Describe at least 3 possible numerical variables that describe the size of a book. And what units would you measure each variable? And I gave you one during class. The one that I talked about was the weight of a textbook. Now, in what unit would you describe it in? You could weigh it in pounds, in ounces, but that's what they're talking about in unit. Exactly how would you measure it? By what unit? So think of other ways that we can describe how big a textbook is. That shouldn't be too hard to think of the other possibilities other than just the weight of the book itself. Okay. Number 4, it says popular magazines. They usually rank cities in terms of how desirable it is to live and work in each city. Describe 5 variables that you would measure for each city if you were designing such a study. Give reasons for each of your choices. So what would make a city a desirable place to live? Something that you could that you maybe could ask people, or something that you think is important. The one I gave in class would have been nightlife. Nightlife, or what there is to do at night, may be an important part, and if people think that the city is desirable or not. But what else would magazines look for to see if whether a city is desirable or not, and try to come up with 4 more. Number 5, you have to flip a few pages to page 10. Number 5 talks about female doctorates. There are data on the percent of females among people earning doctorates in 1994. You have computer science, education, engineering, life sciences, physical sciences, and psychology. Now, if you look, we're talking about in each field, so each of these are specific majors, how many were females that earned their doctorate in these majors. And you can see that it asks you in A to present these in a well-labeled bar graph. I'll give you a hint. If you look above on page 10, that is a well-labeled bar graph for a different problem. But a bar graph, make sure your bars are not touching each other. Make sure you have labeled each major at the bottom. Make sure that you have titled it at the bottom and said that those are the majors. And make sure that you've titled your entire graph and that it says female doctorates or whatever you're talking about. Your graph is at the top. Your vertical axis should go from 0 all the way up to maybe 70. So you don't have to go from 0 to 100%. And the reason is because education and psychology are the highest ones, and they stop at 62. So there's really no reason. So if you want to go up your scale by 10% each one, there's really no reason to go above 70 because there's nothing above 70%. And then B says, would it also be correct to use a pie chart to display this data? If so, construct the pie chart. If not, explain why not. So remember, a pie chart, we need all our percentages to add up to that magic number of 100%. So you can look at these and explain why or why not we would use a pie chart for this. Question 6 talks about accidental deaths. It says in 1997 there were 92,353 deaths from accidents in the United States. 42,340 of these deaths were from motor vehicle accidents. 11,858 were from falls. 10,163 were from poisoning, and 4,051 were from drowning. 3,601 were from fires. So find the percent of accidental deaths from each of these causes rounded to the nearest percent. So for instance, we know there were 92,353 accidental deaths. Okay, so if I want to know how many were from motor vehicle accidents, I'm just going to take that 42,340 and divide it by 92,353, and that'll give me the percent. And for each one, that's how I will find the percentages. Now, the last one, which is what percent of accidental deaths were due to other causes, that's going to be the remaining amount. So if you add up all the accidental deaths, they will not give you 92,353. So the remaining amount is the other causes. B says make a well-labeled bar graph. So the same thing you did in number 5. A bar graph, again, will not touch of the distribution of causes of accidental deaths. So you will have a category for motor vehicles, a category for falls, a category for poisoning, a category for drowning, a category for fires, and also an other category. And your bar graph can be in percentages after you've changed them to percents, which you did in Part A. Part C, would it also be correct to use a pie chart to display this data? So does it add up to 100%, or are we talking about more than 100% here? Would you use a pie chart or not? And please explain why. Okay, as we move a couple pages more to page 16, I believe, then we get to question 7. It's Olympic gold. It says athletes like Kathy Freeman, Rulon Gardner, Ian Thorpe, Marion Jones, and Jenny Thompson, they all captured public attention by winning gold medals in the 2000 Olympic Games in Sydney, Australia. And here are the gold medals per country. If you look, Sri Lanka and Qatar, they got 0 gold medals. I mean, you can look at the United States and see we had 39 gold medals during the 2000 Olympics. We want to make a dot plot. So what I'm going to look at is the lowest number of gold medals, which we've already talked about is 0. And the highest number of gold medals for the United States was 39. So we need to go from 0 to 39. So probably we'll go up by 2 each way. If you went up by 4, it wouldn't really be a huge amount, but your scale should probably at least go up by 2, 4 at the most, to get from 0 to 40. And make a dot plot. Remember, a dot plot is just dots on that number, and if it occurs more than once, then you'll continue rising up the vertical axis. Okay, number 8, the last one. Are you driving a gas guzzler? Table 1.3, which is on page 17, it displays the highway gas mileage for 32 year 2000 cars. So these cars were all made in model in year 2000, and it shows their miles per gallon here. So I want you to make a dot plot of these. So again, we're looking for the lowest and the highest to see how big our scale should be across the horizontal axis. And the lowest miles per gallon that I can find on here, just glancing at it, is 21. And the highest miles per gallon, again, just by glancing, I think I see 32 as the highest. So from 21 to 32, so you may actually go up by 1 each time because it's not that big of a range or a spread there. And then Part B says, describe the shape, center, and spread of the distribution. So the shape, again, we talked about when you make the dot plot, is it symmetric, meaning is it kind of even all the way across, or are more of them on one side or the other? The center is talking about the mean or the median. So again, what's the middle number, or what's the average if you average them all together? And then the spread is the range. What's the smallest, what's the largest, and how far is it from the smallest to the largest? And then are there any potential outliers? Meaning, is there one that sticks out far away from the rest of them, or are they all pretty close together? And that takes you through day 1's homework. That's questions 1 through 8. And that should be all for today. All right, thanks, and see you tomorrow.